Hello, good afternoon. Welcome to the last tutorial of Chords Comet this year. So we have been listening to different talks about how do we get information from the data, and the starting point is you should have a good quality data. And this tutorial is all about how do we assess the quality of the data to start with. There are a couple of presenters. Before we hand it over to the organizers, a couple of things that we need to note that these sessions will be recorded and the link will be shared by the websites. And by design, this tutorial is has two parts. One is a presentation followed by a hands-on session. If by any chance you have joined via mobile or any other devices, you will not be able to do the hands-on session. So the request is please log in from your laptop. The data sets and everything are shared. You'll be able to follow the instructions that the tutorial organizers are going to say to us. With this, without any further delay, let me hand it over to Hima and team. And thank you very much. Yeah, over to you,
Thank,
Hima.
thank you, Chiranjeev. Chiranjeev, can you please confirm if you can see my slides and
Yes.
hear me well?
Yeah, can
Okay.
both.
All right. Thank you. Okay. Thank you, Chiranjeev, and welcome everyone. A very good afternoon to all of you. My name is Hima Patel, and I work as part of IBM Research Bangalore, where I lead a team of brilliant folks who have been working in the space of building tools and techniques for assessment and remediation of data for AI purposes. And today we'll be talking about a slice of the work that our team has been doing here, and also and we'll introduce the concept. We'll talk about some of the technical details, followed by a hands-on session where you can actually try out some of these tools via your own computer, right? So before starting, I'd like to also introduce my colleagues, Ruhi and Naveen, who are going to be co-presenters with me for the tutorial. And I would also like to thank our extended team who have been helping and working on this agenda for the last couple of years. I'd also like to mention thanks to Professor Shrikanta Bedathur from IIT Delhi, who has been our collaborator and academic partner and working on extending the agenda in this space. Okay, so without further ado, right, let's get started. This session will be roughly divided into three parts. We'll be talking about introduction, motivation to data quality for AI, and talk about a broad spectrum of problems and challenges that are present here. Due to limited time constraints, what we've decided is that we're going to pick up two problems and go do a deep dive onto them, explain the concepts, etc., and what is the state of the art in this area. And then for the two concepts that we have discussed, we would do a hands-on session using where we'll introduce a few open source toolkit as well as a toolkit that has been built by IBM and folks in our team. Okay, and hopefully in the end we'll have some time for question and answers. But do not hesitate if you have questions in between. Please feel free to write them in the chat box, and one of us would answer. Okay, all right. With that, there have been so many reports over the last couple of years studying the data science life cycle, studying, which are the blocks, which are the aspects that, are time consuming. And multiple reports, right, as well as multiple academic influencers have made the same point that data preparation is the one that takes the greatest amount of time in a data science life cycle, right? And when I say data preparation, I basically mean everything, right, from the point that you get the data till the point that you start enhancing your features, building a model, etc., right? So it includes all of your data wrangling and exploratory data analysis and data cleaning and whatnot, right? And this is, I mean, this has been well known that this is a pain point and this is a problem that has been existing in the industry. This becomes a even greater problem considering that data science is still a scarce resource in the industry. And the whole goal of our research is to build tools and techniques that can, remove all the mundane work out of a data scientist's job, and that they could focus on on bringing in the domain knowledge, and basically working on the parts that needs human interactions, etc. Okay. So again, right, Chiranjeev mentioned this in the beginning, and I mean, I think this is clear to everyone, right? That why do we care about the quality of data? For a very simple reason, your model. Let's take the case of supervised models, right? Which get trained on data sets, right? They are going to be highly influenced. Their performance is going to be highly influenced by the quality of the data, right? So our whole goal is to do a shift left of the view and look at the data and say, hey, how can I, what are the challenges in the data, so that you don't pass in messy data to the model, realize the model is not working well, go back, look at the data, right, fix something in the data, go back to the model, and so on. So the whole goal is that we want to reduce all of these iterations that takes place while you're trying to build a machine learning model. More importantly, sometimes, a lot of times there are projects that fail because the data was not good in the first place, and you'd realize this only after several weeks into the project, where you realize that, oh, this data really has XYZ challenges, and perhaps we need more data to actually make this project successful, or a different solution, or maybe the project needs to be shut down, right? And our goal is to say, hey, why waste all those weeks before you even get to that kind of conclusion? We want to assess data as, step zero in a data science life cycle, and give out qualitatively and quantitatively, what are the good parts of the data, what are the bad parts of the data, what are the challenges, etc. Right, so that's the larger motivation as to why this field is growing, why it's important, etc. Right. And this field has been growing in the last couple of years in both academia and the industry. As you can see that on the left, I've just selected a few workshops, right, that have been organized on this topic in top database and AI conferences. And so there's a whole, there's a whole, in the last 2 years or 3 years, there's a whole new set of thought processes building around what does data quality mean, what is data centric AI, and so on. And not just workshops and papers, there are also, I think, open source tools and corporate tools coming out, some of which have been listed here, right? So this topic has been gaining a lot of traction in both the academia and the industry, and it's high time that we pay we pay attention to this very important topic and assess the data before we move in the further parts of the model machine learning, building the machine learning model. Okay, so so now that we've defined about largely and roughly the motivation and why we care about it, let's define what is data quality for AI, right? And this is the definition that we bring in, where we want to say that uh, the whole goal of data quality and AI should, you think about it as a library, as a bunch of algorithms, which are, which is a new step in your whole data science life cycle, where you basically are trying to do three things, right? One, you want to assess the quality of data, right? So you need data quality assessment algorithms. Second, you need to be able to make recommendations to the data scientist about what should be done if the quality is bad, right? Which includes not just recommendations, but also explanations and understanding about why is the quality score bad and what is the region of the data that is contributing to bad quality score, right? And then on the third part is, algorithms to actually clean and remediate the data so as to improve the quality of data, right? This could also mean that a data scientist could look at data quality assessments and could also make choices around what kind of feature extraction or what kind of models would they select, and that would be all, I think, other advantages, if we had a workflow like this at the start of the life cycle, right? And apart from all of this, right, as you're making a lot of changes to the data, there's a need for capturing the history of the data operations. So let's I think let's go one level deeper into this, and think about when we say data quality assessment algorithms, what does that really mean, and what are the different facets that one should be thinking about, right? So data could come in, it could be your part of your tabular data or your text data or your time series data. And based on the kind of data that you're looking at, some of these facets may change, but roughly maybe the framework still may remain broadly similar. Let's consider structured or tabular data for the purposes of the discussion of this tutorial, right? And here are, I think, five areas that we suggest that every data scientists should be looking at, in terms of measuring the quality of data. One is in the labels, right? This is, of course, I think the step zero. If there are no labels, you need to get labels. If there are labels are already present, you want to make sure that the labels are of good quality. There are no annotation errors. The labels are not noisy, etc. Then there is a whole set of challenges related to the distribution of the data, right? Think about things like simple things like class imbalance problem, which is related to how the classes are distributed, and so on, right? And what is the imbalance between them, right? And then class imbalance by itself seems to be, in the name way, you could do as simple as just counting the number of points across the two classes. But really, I think the problem is way more complex than that, and which is what I think Ruhi would be talking about in the next session. The other data distribution kind of challenges to think about are, let's say, are the classes overlapping, right? Are there specific regions of the data which are problematic? The next facet to think about is within the whole space of trust and privacy, right? Do you have does your data have bias? Does your data have protected data attributes that need to be taken care of, and so on? Moving forward, right, the other thing that needs to be looked at is the data sanity, right? Which I'm sure, right, might be, I think, something that the audience may be familiar with, things around like missing data imputation techniques, outliers, noise removal techniques, and so on, right? And the final part that one needs to focus, right, is around the data features. Are your features noisy? Are your features highly correlated? Are your features redundant? Which features are important, and a bunch of things around it, right? So do you have a data set where all your features, like, correlate very, very weakly with the target variable? Maybe then you need to do something. You need to pay a lot of attention in the feature engineering space to make sure that the features are strong, and so on, right? So with this, I think we've set the base for what is data quality, why do we care about it, what's a broad framework under which we can understand the problems under data quality assessment algorithms. And in the next, as we move forward, Ruhi would take us through two specific technical challenges associated with data labels and a challenge associated with data distribution. And then Naveen would help us do a hands-on for the challenges that Ruhi is going to talk about. With that, over to you, Ruhi.
Thank you, Hema. Yeah, let me share my screen. Is my screen visible?
Yes, we can see your screen.
Hey, hi everyone. So I am Ruhi Sharma Mittal. So I'm working in IBM Research Lab India as a data engineer. So as Hema mentioned, the dataset can have multiple issues. So for the since we have the time constraint, so I will go deeper into the two of the issues. data labels, and data distributions. So I will try to cover the breadth of the literature in these domains. Get started with the class imbalance. So, whenever there is an unequal distribution of classes in a data set, we call data set to be having the issue of class imbalance. And why this can happen? This can happen in any domain where one pattern is more common than the other. For example, take credit card transactions. So, in credit card transaction, mostly transactions are non-fraudulent or simple transactions. There are rare cases the transaction could be fraud. In those cases, if we take a data set of credit card transactions, we can see there are very few samples of the fraudulent transactions versus the simple transaction. So in this case, our fraudulent transactions present in the minority and will be known as minority class, whereas the simple transaction, non-fraudulent transaction will be known as the majority classes. Then, since okay, the data set can have the imbalance, but why then it is important to handle that? Why imbalance classification is hard? Because usually whatever learning algorithms we use, though those learning algorithm assumes data to be balanced. Similarly, whatever evaluation metric we use, we give equal weightage to the false negatives as well as the false positives. But in the imbalance classification, false negatives are more important to us. Consider the example of fraudulent transactions only. We can't afford any fraud transactions to be gone undetected. In the contrary, we can assume okay, some simple transactions can be detected as fraudulent transaction. We can do further scrutiny on that and make it whether it's a fraud or non-fraud. So that's why in imbalance classification we have to give more priority to the false negatives. Similarly, the domains in which this class imbalance happens, in those domains minority classes are mostly very important to us, but because of the class imbalance it is given the least priority in the classification. That's why with imbalanced data, classification become very hard. Now, to just give you a brief overview why we are saying it's hard and why we want it to handle it, we took examples like five data set from the Keel repository. It's an open data set repository and a very famous for imbalanced data sets. Here you can see these green bars. So these green bars represent when we take data set and we use off the shelf imbalance rectification method, then what is the f1 score, versus this blue represents when we take only the imbalanced data set, don't do any rectification on that, what is the f1 score. So in all these five scenarios we can see once we rectify or use some uh, techniques to handle imbalance, the f1 score is better. So that's why it become very important for the classifier performance that we should handle this imbalance into the data set. Now the question is imbalance is the only problem in the nature? Let's say my data set, what if like my data set is having the unequal distribution, so I will create more data points. And no, not only the imbalance ratio, whereas other factors also contribute to the imbalance classification. For example, overlap between the classes, smaller subconcept, data set sizes, and so on. So I will go into the detail of each of the factor. So first is the imbalance ratio. So more the imbalance ratio, which means more is the distribution difference between the minority and the majority, then more problem it will be for the classifier. Why? Because lesser will be the number of the minority sample, there are very high chances of it getting detected as noise. And in the overlapping regions, it is very high chances that those minorities are not even given importance. Then the second factor is overlap. Here we can see in the figure, the X marks represent the majority samples, whereas the circle marks represent the minority samples. Here we can see the features of the minority and the majority are overlapping. Maybe because of feature representation. So there could be so many features behind, so many issues behind, but we can see there is overlap between the majority and the minority. Now, if we don't do anything for this data and work with this data, then what will happen? The classifier in this overlapping region, which is marked by this dotted oval, the priority is given to the majority. Even the minority samples are present, but usually classifier classifier will detect any test sample lying in this region as majority class. Now, the third factor is small subconcept. Already in imbalance classification, the minority samples are very less. Further, if these minority samples are divided into further subconcept, then it becomes very difficult for the classifier to detect those minority samples. Next is dataset size. So here, as we can see in the figure A, the imbalance ratio, let's say, assume is X. The similar imbalance ratio is present in the figure B also. But what's the difference between these two is in the figure A, we have enough data sample sizes, which means dataset sizes good enough, which due to which we are or the classifier is able to detect the classification boundary or able to detect the underlying structure of the minority class. Whereas if we move to the figure B, here we can see, okay, there is an imbalance, but due to the dataset size, the dataset size is very less, the underlying structure of the minority class is not at all identifiable. Even it will be difficult for us also to identify that the actual distribution of the minority class is the bigger area, not the smaller area. So, okay, so now we have seen that, okay, individual factors can affect the imbalance classification. But what if all these factors are combined into one data set? Are it going to be more difficult? So to tell that, there is paper which is from 2010. They published that hypothesis. So what they did is, in the starting of the paper, they started with the hypothesis that, okay, the factors are not at all dependent on each other. So overlap and imbalance ratio, assume that they created a hypothesis that it is not at all dependent on each other. Using that, they created one formulation to predict the performance, and that performance they represented with the red star. However, when they took that as it is data and ran some classifier on that, the performance they measured, they are representing that with a triangle in a light blue shade. Now in all these figures we can see very well there is too much difference in the performance of these uh, triangles versus this red star. So in this paper, taking that hypothesis, and once they observed that that metric evaluation was very different, which means the hypothesis was false. So they concluded, okay, the hypothesis was false because they were able to see this much difference, which means that all these factors are not at all independent of each other, they are dependent on one another. Now one more thing we can observe from here is, from the first graph and in the last graph, if you can see, there is only a difference of the dataset size, but you can see the performance is too much degraded. Here, in the last figure, if you see, we have 6400 data samples. With those data samples, even if we vary, so this, if you see that green marks, these green marks represent varying the imbalance. With this much data set size, if you vary the imbalance, still there won't be any impact on the evaluation metric, which is represented by this vertical line. However, if you vary the overlap, which is represented by this blue squares, you can see there is a difference. However, if we vary both together, which is represented by these triangles, we can see the performance degrades a lot. This shows when all these affecting factors combine, then the degradation in the performance will be too huge. Okay, till now we saw, okay, data can set can have imbalance in nature, and there are factors also which can impact it, and it affects the classifier performance. So once we know, okay, it affects the classifier performance, we need to do something to handle those imbalance in the data set. So there are various strategies which we can follow. We can do that handling at the data pre-processing level. We can do post-processing also. We can work with the hybrid model, as well as we can learn very specific learning methods which are very sensitive to the imbalance into the nature. So due to time constraint, today we will only talk about this resampling methods which happens at the data pre-processing level. So here are some heuristic based approaches to handle imbalance into the data set. So first approach is known as undersampling techniques. In this, we can see this orange represents the minority data class, whereas this blue represents the majority data class. So we can see there is a difference in the number of data samples in these two classes. So in undersampling, what usually algorithm does is from the majority class, they select few samples so that the number of samples in the majority and minority will be equivalent at the end. And few examples of these algorithms are Tomac link, ENN, and CNN. Whereas in the oversampling techniques, given very less number of minority samples, algorithm create or synthesize data samples so that ultimately the number of data samples in minority and majority class will be equivalent. So few examples of these type of algorithms are Smoote, borderline Smoote, so on. Now there are few hybrid techniques also to handle imbalance. So first, those hybrid techniques does is they do oversampling so that there will be equal number of samples in both the classes. And further to reduce the noise into the data or to clean the data, they do the undersampling. And few examples of these type of algorithms are Smoother Tomac and Smoother EN and so on. So one thing, all these uh, algorithms are usually heuristic based. Now we have seen, okay, there are algorithms present which by which we can handle class imbalance problem. But the big question is, does imbalance recovery method always help, or does the impact of imbalance recovery method is same on all that data set? And the answer is a big no, and which was presented by this paper which got published in 2019. Let's see these three scenarios. In figure A, we can see these blues are the minority classes and these browns are the majority classes. Here we can see these two classes are very well separated. So without even handling, and we can see there is an imbalance. So without even handling the imbalance, the classifier will be performing very well because there is a very clean boundary between these two classes. These two classes are very well separated. So without even doing anything, the classifier will perform better. And even if we, let's say, apply any imbalance recovery method, the classifier performance won't change. Now consider the figure number B. Here, the classes are very much overlapping. It's totally overlapping. Now, in a raw data space, in a raw space, if we see without handling imbalance, the classifier performance will be not that good. But let's say if we apply some recovery method, in this case, even if we apply some recovery method, the classes are so much overlapped between each other, the impact won't be too much, or there will be no impact to it. Whereas if we can see the third scenario where the classes are overlapping very marginally or partially overlapping, in this scenario, if we apply any recovery method or generate, let's say, data point, synthesize data point in this region around minority class, or from the majority class remove data points from this region, then this region will be very prominent for the minority classes and there will be very high impact on the classifier performance. So this paper actually brings this idea that whether we should do something to handle the imbalance in the data set or not. Let's see the formalization they used in this paper. So in this paper, what they do is, to each minority sample, they first provide a score to it, which they call as IBI, and which is the difference between normalized probability between the imbalance case and the estimated balanced case. So once they provide that sample, this score we can assume as it is providing, okay, what will be the impact on this particular minority sample once we apply any recovery method, or once this point will lie in a very balanced case, then that score is IBI. So now to provide a score to the data set to know, okay, whether if I apply uh, imbalance recovery method on this data set, what will be the impact or how much will be the impact, they provide a score to the full data set, which they call as base impact score, which is denoted as BI3. So how they do is they average all this IBI on the all majority samples, and that score they give to the data set. Now, higher that score for a particular data set, then higher will be the chances that if we apply any imbalance recovery method to that data set, the classifier performance will be performance will improve. And they showed that in their experimentation also. So this is now one another interesting paper in this domain. So till this point, we have seen okay how to apply heuristic based method and all, but this paper actually come with an argument that if you want to do resampling, you should include the ultimate classifier which you want to use along with the evaluation metric which you want to use into the process only. So let me tell you the formulation for how they formulate the paper. So assume we have a training set, and from that we have a subset SA which is denoted by SA, and the training set is denoted by X comma Y. Assume that there is a data sampler W which will take full data set and which will give us a subset, and we ultimate goal uh, is to learn a classifier F, and the evaluation matrix is G. So now the problem is how we are going to learn this data sampler, which is W. And that data sampler should be best possible because we want to maximize this evaluation metric. So here the key idea of this paper was they parameterize this data sampler and train it to optimize the classifier performance. Now this actually optimization problem is a non-differentiable. So that's why they used reinforcement learning for this problem, and they model this full problem as sequential decision making process and then solved it using policy gradient. So that's all from the class imbalance side. Let's start with another issue which can happen in a data set, which is known as label noise. So, label noise, we say, okay, data set is having label noise when we see there is misclassified, not misclassified, mislabeled data in the data set. Let me give you a few examples. So, in the right side, we can see from the data set Google Quick Draw. This is one figure, which obviously looks like an elephant to us, but the actual label given to it was mosquito. Similarly, from the MNIST data, this image is there, which is actually a digit 3, but the given label, provided label was 5. The another example is an Amazon review, which is very positive review. However, the given label to it was 1-star reviews. So we all can see all these are mislabeled data actually. Similarly, this is a tabular data. The given label to the highlighted row was Iris setosa. But if we look at the features of this, it looks more towards the Iris virginia class. So this is a very common problem in data sets where even in the literature it is very well known that ImageNet, which is one of the largest image data set, having hundred of thousands label noise issues. So okay, so data set is having label noise. Now what could be the sources of that? So since data set is sometimes manually labeled or semi supervised way labels, there could be errors in that labeling itself, and because of that few samples can get mislabeled. It can depend on the subjectivity of the labeler also, or labeling task also. For example, let's say if I'm labeling something and it's an image of a swimmer with a swimming goggle and a swimming cap, I can label it as a swimming or a swimmer, but another person can label it as a swimming goggle, and another person can label it as a swimming cap. So it totally depends on the subjectivity of the labeling task, and when the communication is not proper or there is an insufficient information to the labeler, all these errors are prone to happen. And so what is the effect of label noise on the classifier? For sure, because since our training data is not well, they have mislabeled examples in it. The classifier performance degrades due to this, and it poses the threat to another task also. For example, feature selection. And in online setting, where we receive continuous data, the new label can contradict with the original labels because there are labeling issues here. Now, we know, okay, labeling issues can happen. So, what are the techniques to handle those? So, the techniques can be broadly classified into two types: algorithm level approaches and data level approaches. In algorithm level approaches, the main motto is to design robust algorithms so that it will become insensitive to noise. Whereas in data level approaches, before going to any ML task, we want to handle this noise or we want to filter out those noise. In algorithm level approaches, since we are handling it at a learning algorithm level, it is not generalizable solution. Solution for one learner won't be applied to the another learner classifier. So similarly in data level approaches, if we do this data pruning or filtering out the noise at a data level, so that will be equivalent to all the learners. I can use learner 1, learner 2, learner 3, any learner for this. So it is actually a very generalized solution as compared to the algorithmic level approaches. So, due to time constraint, we will today focus on the data level approaches only. However, we have listed down few literature, very well-known literature from NEBS, AAAI in these domains. Let's get started with the data level approaches. So, here are few algorithms or papers which come and which acts as filter-based approaches. So, what are these filter-based approaches are? Before going to this learning algorithm, we should filter out all the uh, samples which we think are label noises, and then only all this correct labels or the data samples which we think are clean without noise should be taken to the learning algorithm. So this is usually known as filter based approaches. So one paper which got published in 1999 in Journal of Artificial Intelligence, that paper is known as identifying mislabeled training data. So that paper actually works on the concept. They take full data set and they make parts of the training data set and train filters on those parts. So we can assume it or we can relate it to the cross validation. So how in the cross validation we train our classifier on part of the training samples and uh, take the remaining sample for as a testing or validation data set. Similarly here, they do the similar way and then they train let's say ensemble n numbers of filters. Once they have n numbers of filters, and for the remaining data set they pass it through the all the filters. Now once all the filters have their predicted labels, now we need to know, okay, which data samples are noisy and which are not. So they have then voting schemes. If majority of the filters, let's say if we have x filters, then if more than x by 2 filters are saying that the current label, let's say the ground truth and the predicted label are not matching for most of the filters, then we call it as a label noise. And there is another type of voting which they propose, that is consensus voting. In that, if all the filters are misclassifying that particular data sample, then we call that particular data sample as label noise. Now, there is another paper in this domain on the labeling correctness is computer vision data set. It came in 2018. What they did is they trained CNN ensemble to detect the incorrect labels, and the voting scheme which they used was majority voting. Another paper which came in 2017, finding label noisy examples in large data set. What they did is their process is actually a two-step process. In first step, actually, they take full data set as it is and they create SVM classifier. And whatever examples are not uh, support vector examples, they call it as very potential candidate of noisy data point. And whatever samples are not support vector examples, they call it as a clean data samples, noise free data samples. Now they take that noise free data samples and then they train another classifier on it. And using these whatever the potential noisy samples, they take those as a testing data point and pass through that classifier. If that classifier is misclassifying those potentially noisy samples, then only they say, okay, that particular sample is a noisy sample containing label noise. Another interesting paper in this domain is confident learning, and it is very well known as a clean lab also. So it actually works in a principle, three principles. First they search for the label errors, then they prune that label errors by counting, and in the end, after cleaning the data set, what they do is they still train without the error the data set, but reweight all the examples by the class weightage. So I'm not going into the depth of this paper for the formulation because of the time constraint. Just assume with the formulation given in their paper, for each data sample, they have created one confident joint matrix. Using that confident joint matrix, they normalize it, and that they call as Q. Now let's see how they prune. Once they have, let's say, this normalized confident joint matrix, how they prune it. So for pruning the data, they have few methods. So the first method they call as C confusion, which is like normal confusion based on ML. They use that and they call all the noise and they prune those off diagonal elements. The second method which they prune is confident joint matrix. So rather than using the confusion matrix, they use the confident off diagonal off diagonal elements there also. Another method which they propose is pruning by the classes. So in each classes they go and they have a goal. From the each classes they select n numbers of sample, and which n number they select n numbers which are having lowest self confidence in the metric. Next method which they use is prune by noise rate. So what they do here is they take that off diagonal entries, but they don't prune everything from the off diagonal metric. They prune only samples which are having very maximum margin. And in the last method, they combine this prune by class and prune by noise rate. In the paper, they have shown that the method prune by noise rate is giving the best performance. So here we can see from their method, what they identified is the 32 top 32 mislabeled issues in ImageNet. So here in the red, whatever images are encircled in red, those are actual errors. For example, in the first image, we can see actually the label given was drum, but guess was jigsaw puzzle. Then whatever is marked in the green boxes, those are the ontological issues. What do they mean by ontological issues? Like given and guess are having interrelation, like is a type, something like that. For example, take example row number 2 and column number 1. Given was CRT screen and guess was oscilloscope. Actually, CRT screen is a type of oscilloscopy. So, which mean in ontology they are having that relationship. That's why it got mislabeled. And the multi-labeled images they have marked in the blue boxes. For example, take a case of this third image, row 1, third column. So the label given was dog. However, the guest was container ship. It could because the multiple because it could be an image of dog also and container ship also. That's why it's a mislabeled due to the multi-label image. Okay, so one more, this is another paper which I am going to talk about. This actually come in 2021, known as Data Quality Toolkit. It is actually built on top of this confident learning based approach, which we discussed previously, Clean Lab. So one limitation which Clean Lab is having actually in the overlapping region, wherever there are two classes overlapping with each other, those overlapping region, they sometimes normal samples like non-erroneous samples also, they call those samples as label noise, which means they are very high prone to false positives. Whereas it is not always the case that whatever is lying in an overlapping region could be a label noise. So this paper handles actually that limitation of Clean Lab, and they handle the problem in two ways. First of all, they develop an algorithm in which before going to identifying the label noise, they develop algorithm which detect the overlapping region, and then they call this separately, and on the remaining data they perform this label noise identification. And the second way they handle this is for their pruning, they actually use an effective neighborhood based pruning mechanism to remove the noisy candidates. To compare the Clean Lab with this paper, they have shown a few experimentation in their paper. So first graph, if you see here, is the precision graph on 35 data set. Here we can see that orange bar is actually Clean Lab precision, whereas this green bars, this blue bars are this paper precision. Here we can see in this graph, almost every time this paper's precision is very high than the Clean Lab precision. On the contrary, if we go to the recall, we can see there is a minor drop in the recall. So this paper also claims that there is overall 5 to 16% improvement they have made in the precision as compared to the clean lab, but at the cost of recall drop, which is not very significant also. Hardly 2% drop in the recall, they made an improvement of 5 to 16% in the precision. So yeah, that's all from the issue side. Now I would like to hand over it to Naveen. Naveen will go through few toolkits in the market for the data quality. So over to you, Naveen. Let me stop share. Naveen, are you? You are on mute, Naveen.
Yeah, thanks, Rui, for covering the part. And yeah, as let me quickly grab my share. Yeah. So I think we have seen good motivation from Hema and good technical deep dive from Ruhi. I think as this was the hands-on session, so we thought like we will get our hands dirty, or at least we'll show you like if let's say if you want to analyze the quality of your data, how do you do it? So on that note, like let's just move to the what is the data quality toolkits which are available in the market or in open source domain, or are there by the like commercial offering. So I have listed like few prominent one here. And if we see in open source category, there are like Pandas Profiling, Deep QA, TensorFlow data validation, and there is a data measurement tool by Hugging Face. And then there are like commercial tools, or like trial offering which is there, and one from like data quality for AI, which is by IBM research, and on which we gonna talk and show the hands-on experience today in later. And then of course know your data by Google, and that Google is there. So I think by looking at this list, if you are seeing like it's a data quality issue is not in the one domain. And if you see like Pandas Profiling, Deep QA, they worked on structured data. On the other hand, we have a data quality toolkit in text data or unstructured data as well from a Hugging Face. Or it's the same problem with image data domain as well. Like as you see like know your data toolkit, it's on the quality of the image data set. So I think all this like having said that, like all these tools are there from a different domain. I think that's again emphasize on the need of having such toolkit. And on that, I think whatever I marked here in purple, I think I'm gonna go through that, and I'm gonna show like how we can use this data quality toolkit if you want to use in your day-to-day life or with your data set. So I'm gonna go over next with the Pandas Profiling, and how can you use the Pandas Profiling, and what all things are there. And again, TensorFlow validation, just to cover on a breath, like if there are like TensorFlow users and all. And then we'll go and do a big hands-on on a for next half an hour or so on a data quality AI, which is in on form of APIs, and we'll do an hands-on on that part. So let's move to the first tool, Pandas Profiling. And as name suggests, I think this is the tool. This is built on top of the Pandas library, and Pandas is like a prominent library in a Python to do all the data science activity, and all your day to day like data handling, or doing a model and all. So I think the very quick way to do is like you can just do a pip install Pandas Profiling. And once you have installed the Pandas Profiling library, I think it's a straightforward three command or a three line of code which I just listed here, that you can import, and then you can do profile report on the data frame, which is DF. So you can load the data, your data into data frame, and just you can do a profile using the profile report function call here. So by doing this, I think you can get the output in a notebook itself, or if you want to get the output in a form of nice HTML, what you can do here is like profile.to html, and it will give you a nice formatted output in a HTML format. So if you see, I think I have just given a snapshot of what would be the output of Pandas profiling, and it's mostly on like we see on a typical standard data quality issue, which is like what is the type of that columns which I'm having, or what are the quantile range of my columns, or what are the missing rows, missing values or duplicate rows. So if I look at this chart, Pandas profiling cover most of the basic matrices, but again the some of the advanced data quality issue which Ruhi was talking about, like class imbalance, or handling the class imbalance, or finding the label purity, or a label noise issue in the data, they are still missing. So but even for your, if you want to use Pandas profiling for your basic needs, I think you can just go ahead with this small 3 line of code, and you can just get started. So now let's look at the second tool, which is available in the open source domain, which is like by the TensorFlow, and it's called TensorFlow Data Validation. And again, like if you want to use the same TensorFlow data validation tool, what you can do is like pip install TensorFlow Data Validation. This is again a Python based package. And if you want to, like, let's say, generate the visualization, or you want to compute the quality, or some kind of statistics from the data, I think there is a quick function called generates statistics from TF record, and what you can provide a data location path, and it will give you an stats, and you can visualize those stats in a notebook, or you can like save it in some file or not. So here I'm just using to show them in a notebook, and this is the example I have taken from their official documentation. So here again you see, like, I think going over this, I'm stretching our same point here, that what all the functionality available here. I think these are the functionality listed by the TensorFlow on their documentation. Like, they compute the descriptive statistic on the data which we seen here, like what is the total value, what are the missing percentage, and what is the mean value, what is the standard deviation. And they also do an automated schema based thing, like infer the schema, what is the column type, or is it a text data, or is it a categorical data. And they also have a functionality of to detect the anomalies. So I think in that regard, like if you want to detect the anomalies in your data, and if they are not if you if as I said, like it was not part of the Pandas profiling, you can use TensorFlow data validation to do that. So again, like TensorFlow data validation cover one more steps toward the some of the like advanced or good quality data quality issue. But still, this also is, there is a lack in like what all the like as like advanced metrics which Ruhi was talking about, imbalance, or like label purity. Like for that also, there is a need to have some open domain data quality toolkit. So yeah, but having said that, like all this toolkit, Pandas profiling and TensorFlow are mature enough. And if you have a such kind of a need in your day-to-day life, where you want to analyze the basic quality of the data, please go ahead and try these tools. And these tools are like really handy, and they can be as a first start or as a gateway to the whole data quality for AI. So they can give you that experience. Okay. So now I think we will be moving toward like data quality for AI by IBM Research, and this is the toolkit which we have talked about. And I think we have posted the links for this toolkit available. So for now, what I'm gonna do here is like I'm gonna give a proper hands-on session. Like if you have your own data, how can you access the one of like data quality for AI APIs which are available publicly for anyone to use it, and how can you register for this API, how can you interpret the output of this API, and what all kind of data quality we can measure in this toolkit. So on that note, let me go to the data quality for AI page. And I think we have shared the link, and if not, like, please let us know in the chat. I think my co-presenter Ruhi and Hima can share all the links which I will be presenting here. So this is the data quality for AI APIs which we have built in last 1 year. And if you see here, I think we have all the APIs, all the data quality issues we have given to the user in a form of a API call, or we call it as an APIs, open APIs, and they are available on IBM Developer platform. So if you see here, like what all APIs are available, I think we have like from label purity to class parity, and all other like basic to all other advanced metrics, like getting the class overlap, correlation detection, data completeness, data duplicate, data homogeneity. So we have a exhaustive list of APIs available which can measure, and this API can give you a measure of a data quality on a individual dimension. And for all this, like you can go over the details of what this API does, or I think Ruhi already explained. They It's already present in the overview section here. And now let's see, like, let's say if the label purity is something what you want to use it, which Ruhi talked about earlier, how you use it. So if you see here in API section here on my right hand side of the screen, there is the option of try this API. And let me just click on this. So once you see, there is an once you click on try this API, you see there is a security thing where you being asked for a identification and client secret, and then there is a option for a data file and a label column and some additional optional parameter. So then I think, like, to access this API, now we got the information that we need some kind of a client ID and client secret. And this is the place where the registration link which we have circulated earlier will come into the handy. Like, to use this API freely, like, at least you have to subscribe to this APIs. So to subscribe to all of this API, like, you can just do this get trial subscription, and we what we redirect you to here is a registration page. It's a very simple registration page. You can fill the basic information and your name, and set account for yourself on a IBM developer profile. And once you, like, filled out all these details and subscribe to our APIs, you will be redirected to IBM Developer Dashboard. And this is a common dashboard, so if you already have a IBM developer profile, you can log into IBM account. And if you don't have, just register. I think it's a simple few steps. So once you be on IBM Developer Dashboard, you on under the API section, which I clicked here. And in this API section, you can find, like, there is a subscription for data quality for AI API. So let me just quickly click on that, and here it will tell you, like, what is the details of your subscription. So if you see here, my days are remaining like 52. So by default, we give everyone as a 180 days of a free subscription. And you can use, like, for the, like, 6 month, you can play around with these APIs, and you can see what is there, or whether it's a useful for your use case or not. So under this, you will find there is a key section, and here you can quickly see, like, client ID and client secrets are present. So and these are the client ID and client secret you can use to access the all the APIs which you have. So now what let me do here is, like, copy this credential from here into my uh, option on API Hub, and I copied my secret as well. And now I think that there is a parameter option. So by default, I let them what it is. And now let's see, like there is an option to upload. So right now we are working with the tabular data sets, so we are asking users to upload the any CSV file. So I have a one data sets, it's it's on credit data set, what we call. And what this data set has is like given the personal information, like a person credit history, whether we should give a credit card to that person or not. So it's an open UCI repository data set, and this data set is publicly available. And if you can't also find it, I think we have also provided a Google Drive where we have put together a few public data sets which are available in the public domain. And what you can do is like you can use those data set to play around all these APIs. So, and for other like label column, I'm just leaving this as an optional here. So I'm just leaving this column. So let me expand this for a better visualization. Okay. So let's say now you have filled your client ID, client secret, and you filled your data, and you wanted to analyze this data for a label purity use cases. So now let me run the request for it. So what this does here is like on this API call, we take your data, and what we do here is like we give you a job ID that we acknowledge that we have taken your request for the label purity data quality things. And in the background, while we evaluate your data sets, this is the job ID. You can come and check regarding to what is the status of uh, your data quality job which you have submitted. So as you can see here, like you get the 200, okay, it means like everything went perfectly nice, and you get the job ID and message saying that this job has been submitted. It means like we have taken your request, we are analyzing your data. And now what you can do here is like using this job ID, you can always check what is the result or what is the status of the job which you have submitted. So now how do we get the jobs results for this data quality thing? So if you see, there is a get results section. So let me go there, and in that, if you see, like my client ID and client secrets are already there. All it's asking is like give me the job ID so that I can fetch you the result or a response related to the job which you have submitted. So let me run this request and let's see what comes out. Okay. So if you see again, like we got like 200, uh, 200, okay, that whatever request you put to it went successfully. And this time, if you see for this job, the status is job submit, job finished. So it means like we have finished analyzing your data, and this is the result which we got. Okay, so I'm now shifting to the like good previously like fetched result just for a better visualization. So all the for all the uh, for all our quality metrics, if you see here, like we always give a result or a response in a very structured format, that you will get the job ID, you will get the message, and entire response will be in a response section. So if I just open this response, and this would be common for all the quality metrics which you have, you will get the few metadata related to the job you submitted, like what was the file name, and what what is the method you were trying to do, like finding the noise ratio or noise sample, details related to method we ran, and the actual result. So in the result section, if you see here, the title was label purity we ran, and the score is 0.98. So let me again just a pause here and explain you what we mean by score. So for all our quality metrics, what we do here is like when we do a data quality analysis on a particular dimension, be it a label purity or a class parity or a class overlap or a outlier, we always return a score between 0 to 1, and where 1 signifies it's a really good quality of the data and 0 signifies it's a really bad quality of the data. So here we see is like 0.98 score. It means like it's very near to 1. It means it's a good score. But again, why it's a 0.98, we give us some explanation for all our metrics as well, so that like it's not a blind score or a blind result. We also give a proper explanation why we reached toward the certain score. So if you see, noisy label detected in a 21 rows out of 1000 rows. So there were 1000 rows in the data set, and out of that, like there were like noisy labels were there in 21 rows. And I think to detection of this noisy label, I think Ruhe has already talked in details. So I'm gonna skip that, and I'm just gonna cover like what all additional details we provide. So not only this explanation, we also give you a detailed analysis of the result, like confusing noisy sample, which are the sample, or which are the row id which lies in a noisy region, and also which are the actual noisy label, like why we are calling them as noise label. So if you see here, like we give a detailed list, like we are calling row number 80 as a noisy row number 80 is having a noisy label. It means like the actual label for this column was 1, but this that was a wrong label. And what we suggest to the data science or a AI person or a AI researcher, that the label for this particular row should be 0. So it's up to the end user who is using it. They can take this data quality suggestion and they can modify their data frame, or they can change the label in their data, so that it's they get good performance or not. So on that note, I think we again pinpoint the problem, like this was the overall problem, giving out the score, and what was the pinpointing the exact problem, where are the noisy labels and noise suggestion. So that's, I think, one end-to-end flow. And as I said, like this would be like one flow which we're gonna do. And what I'm gonna do here is like I'm gonna pause for like 5 minutes or so, so that like people who are having a laptop and wanted to try out in a online fashion, and if they are facing any trouble, they can let us know. Or if you are having any issues by accessing any of this thing, like please post in chat, or have any question, just put that on a question section. Okay. So Ima and Rohi, I can't see the questions. If there are any questions, please like to speak out or let me know.
Yeah, there are a few questions, Naveen, which I think right now we are answering. If since we are waiting, there's also a poll. So anyone, if you are able to register, please mark in the poll so we'd get to know that
Mm.
you're able to register yourself to the APIs easily. And then once you do that, we could go forward and try out. You could try out for a given data set, and we could do that step by step.
Yeah. And just for people understanding, like whatever end-to-end steps which we are presenting today, like even if you are not able to try out today, and if you wanted to try out later, we also have a detailed step-by-step tutorial on like how to do it on IBM Learning Path. You can find the link here on introduction section, IBM Developer Learning Path. If you for some reason, if you are not able to try out today, just, and if you want to try out offline, just go over this all this tutorial. We have given the detailed list, like how can you set up the environment, and all the step by step, which the guide which I just uh, shown you. You can get all those details here, and you can get started using it as well. And if you face any problem, like you can speak out today and later days also, if you are trying this data quality for AI's APIs. And if you wanted to reach out to us, we have a open community Slack channel and Slack workspace. You can join this workspace, and I think I updated the workspace invite link as well, so that you can also interact with us. So we have a very big team working on this, and everyone, like as a community, we can answer your queries there, if they are related to data quality for data quality domain. So yeah. And there is a standard FAQs like what all we can support and what all things we can do, and if you get any error while submitting your job or your data, you can first refer to our FAQ page as well. It's a FAQ page available here, and you can also let us know on a Slack workspace, so if we can see if we can resolve any of the issues which you are facing.
So Naveen, there is a question from Vijay Lakshmi. So is the free trial will expire today only?
No, free trial, as I said, free trial, what we are giving is like everyone a free trial of 180 days. So I registered on last year in December. So I have only 2 days remaining, but all the user will get an 180 days of free subscription. So you can try in like at least in next 6 months, you can try out this tool for your data set and see uh, whether you can get the uh, quality of the your data which you are having. So it won't expire today. It's if you register today, it will expire on 181 day. You can always get the details of your subscription and registration which you are giving on that API section which I was talking to you. So it's always present in your profile, that when is your subscription ending and all, so that if you are working on a project you can plan your deadlines according to it. Okay. So if there are no question, I think I can again show you the again like one more flow on a different metric. All those people who are following, if you are having any question, they can again follow these steps. Just to have your. So let's just go over the one more metric which Ruhi was talking about. It's a class parity, and let's say like if you wanted to try out all others metrics on a overview section, you always find a detailed introduction, just for your sake, like what this actually metric does. It's not only for this metric, so any of other metric you will find very detailed answer, or overview what is there and how can you interpret, or what kind of information you will get for the data. All these things are present here. So again, let me go for the try this APIs, and now let me copy my credential again. Just for this thing here. Yeah. Yeah, and I'll just leave the optional parameter as it is, and I'll just go with my data, and I'll again select the same data, and I'll just do a run request. Run request. Yeah, and if you see here is also, if I want to get the class parity data quality issue in my data, I submitted the job for it, for data set which I had. I just uploaded the only CSV file which I had. I got the job ID which saying like we have your job is submitted. Now if we go and see, let's check the result. So I go to the get results route or get result API, and now let's see what do we have. Okay, so for this as well, if you see for this job ID, my job is finished, so it means I got the results. And again, just for a better visualization, I have put this entire into a nice formatted JSON. So if you look at here now, again this JSON has a exactly same structure as the previous one, so that like it's always for you, it's always be a consistent report or a consistent result. So under the result section, let me again go through like what metric we run, what is the score, and what is the explanation for the score. So if you see this time score is like pretty less, which is like zero point 0.5. And why is the zero point 0.5 score? I think there is a detailed explanation in HTML format here, that the parity score is given for the data is zero point 0.5 because sample distribution per class is like for 0th class is 700 sample, and for one class it's a 300 samples. So by looking at this quick overview, you can see there is a proper imbalance. And then we are also providing lots of additional information. I think like putting an imbalance ratio based on a Shannon entropy, it's a like point 0.8, and all other thing like percentage of the difficult sample. So it's, as I said, it's not only one score. We always give a try to pinpoint the problems where it's happening in the data and try to give you a more natural explanation so that it's easier to understand, and you and data scientists and data practitioners can solve this issue when they know where exactly the issue is. And then again, for the class parity, if you see, we are giving a index of a difficult sample. So I think, as Ruhi was talking in her talk, is not the overlap, the when there is an imbalance, that imbalance can occur at many places, and which are the difficult sample where like having imbalance on those sample, it's hard to like debug, or hard to solve that problem. So on that note, I think we are giving a list of all the difficult samples, and you can again choose to like how do you iterate, or how do you want to use this information in your ML or data science pipeline. So this is again the similar thing which we have seen in the label purity. And for all other quality matrices which we have, I think, which are listed here on our page, which is like class overlap, correlation, data completeness, for all those you will find a detailed overview and the detailed explanation of a result in the results JSON. And all the results JSON will always be in the same format, so that it's always easy to understand to the end user. And yeah, feel free to, I think, try out. I think we are giving the like from our side, we are giving like all the students and everyone who is working in this area for like 180 days of a free subscription. And you can get your hand dirty and you can play around, and you can give us also feedback on our Slack channel or anywhere, like how do you find this tool, or how do you find this APIs, or if you are facing any trouble or anything. And having said that, like I am also excited. Like currently we have for structured data, and very soon we will be adding it for the time series data, and you might see like more of the version coming up in upcoming months from our team and our extended team, uh, from a different from other globes. Uh, yep. And any question anyone has it, or anyone facing any trouble while trying this on hands on? Okay, so if there are no other question, I think we can move toward the like I can conclude my hands-on session. Like we have provided the additional resources for you to try out and all other additional details. I think it's already there in the chat, but just wanted to highlight in the presentation as well. And if you wanted to know about the area which we are working, or more about the data quality in general for the machine learning task and all, we do have a like tutorial in other conferences. You can go and watch out, and you can go and learn from those places by going through these links and all. And yeah, and I think that conclude most of our session, and we can have a now a open question answer session, or a feedbacks, or any suggestion, or any question you have on technical presentation which Ruhi had done on a class parity or a class imbalance. Yeah.
So maybe a quick suggestion, Hima. So if you can create a some kind of form where people can register to basically try this demo, and then you can take this forward later on instead of just hosting this just for this session. That will be helpful.
Yeah, sure. I think thanks, Chiranjeev. Great suggestion. And folks, um, The APIs are available. We have a Slack channel that we regularly monitor. So even if you were not able to immediately with us register and try out the APIs, you could. Naveen is just showing right how to join the Slack channel. Please join the Slack channel, and if you have any questions even later on, feel free to post a comment there, and one of us would respond. So Chiranjeev, I hope that I think
Yeah, it'll be good.
answers.
Yeah.
So now question is, how do we publicize the Slack channel when we close this tutorial? So probably the Cord's website in your uh, web page. I think if you
Hmm.
just update this information, people can browse it offline.
Sure.
Yeah, I agree. I think that's a great idea.
Yeah. Yeah. Yeah.
I think overall it was a very nice session. So I think a lot of information. So and but I personally think that over the last few 4 days there are so much of information that's been circling around. It's overwhelming. So
Yeah.
we don't know. So how do we basically take this and then keep this momentum? I think that's probably the most important part, to keep the momentum. Otherwise, somewhere in next conference, next tutorial, we have to revisit, and almost half an hour of the tutorial goes in revisiting and then bringing up the old stuff. I think creating a vibrant community around is probably the most important part, because whoever is the data practicing this data and AI and performance stuff, for them, uh, as far as I know, that there is no industry standard, right? So probably that's the time that we should all push for a forum or a standard, and maybe that's a suggestion that I will also give it to the community, that the organizers, because standardization is very important, because what works for me and then what looks like a standard practice, right, might be very different to you.
Yep.
Yeah, I think this is very interesting session as such, so thank you very much for this.
Yeah, thank you for
Yeah,
thank you for
then
inviting us. Thank you for the nice questions on the chat, and let's keep the conversation ongoing. Right, if there are any questions we can take right now, or even if they are later, please feel free to ask them via the Slack channel. Also, please try out the API, see how it works on your data set. And these are trial APIs, like I said in the chat. There's a more wider set of functionalities available. So if you're interested in trying this out, please reach out to me on Slack, and I can help how that can be enabled for you. Okay.
good, great.
Great.
I
Thank
think
you.
if there are no further questions, we can give people their 7 minutes back. So,
Yes.
Yes.
okay, good. Thank you. Thank you
Okay.
very
Thank you,
much.
everyone.
Yeah.
Yeah.
Bye.
Thanks.
Thank you.
Bye, guys.